All right, so first of all, we're not going to do this activity because I found, and you'll see this to be true in your class too, that it's going to take most of the hour just to get through this without an activity. We'll still do that activity on a different day, but turn to this slide right here. It says 1 radian. All right, so do you get that in a circle that these blue things would both be a radius? Right? They're both a radius, so they're both the same, whatever they are. If they were like 8 inches, they're both 8 inches. All right, so if you draw this in a way that this part right here was also 8 inches, even though it's on a curve, do you guys know that's called an arc? All right, that arc, if that's also 8 inches, if they were all 8 inches, doesn't even matter what they are, but they have to all be the same, then you've got a radian. This thing right here is called a radian. It comes out to about 60 degrees. It's not 60 though. It would be too easy if it was 60. It's just a little less than 60. It's about 59 degrees. All right, so that's what a radian looks like. It's a bunch of it's a bunch of degrees. It's kind of like, some kids are like, why can't we just use degrees? Well, that'd be the same idea as saying, why can't we just use inches to measure everything? Couldn't we say that, you know, the spaceship that's, you know, maybe 500 feet tall, couldn't we measure that in inches? You could, but it's handy to have more than one kind of unit. You don't want to just use inches for everything. All right, so radians. How big are they? About how many degrees? 59, very good. It's about 60, okay? So if I said that that was about 60 degrees, and then I do another one that's about 60, and then I do another one that's about 60, do you get that that's not quite 180? Yeah. If it had been 60, 60, 60, then I'd be to 180. Here's where 180 would be. That's where 0 degrees is. That's where about 60, about 120, and this would be exactly 180, but we didn't make it there. 1 radian, 2 radians, 3 radians. How much do you think the extra is? 3.14, exactly. That's where pi, well, it's not where pi comes from, but pi is used right here to say 1 radian, 2 radians, 3 radians, 3.14 radians. Pi radians. All right, so what you need to connect in your mind is the 180 and the pi. Pi and 180 are equal to each other. Guys, zip it. I'm going to have to move you if it keeps going. All right, so the 180 and the pi have to get connected in your head. And so if 180 is like pi, then I ask you, what's 90 like? If 180 is like pi, what's 90 like? Very good. That's it. I'll draw it right here. If this is an angle of 180, and you might be thinking, how is that an angle? Well, if I have an angle that opens up all the way, you know, like all the way from here to here, that's a 180-degree angle, and that's pi. Oops, 3 things. That's not good. Just imagine there's only 2 of them. All right, so then this spot right here would be at 90 degrees, and it would be at half of a pi. That spot right there, 90 degrees or 1/2 pi. All right. So you're going to get used to radians. So when I say something like, oh, this one's at 3 pi over 4, right now that might not make much sense, but by the end of the hour, you should be able to go, okay, that's 3 pi over 4. 3 pi over 4 is like 3/4 of a pi. So it's 3/4 of the way. So it stops like right there. That's where 3/4 pi is. That's a number of degrees also. You're also going to learn how to change this into some number of degrees, question mark degrees. Then you're going to learn how to figure out how long an arc is. So if I say I got this and this, make this wedge of my circle, do you get that's an arc length? You're going to learn a formula for that. And last, today, you're going to learn how to find the area of a wedge of a circle like that. That's a sector of a circle. And I have to teach you what a radian is, but I already did. What a radian is if you have any spot where you get the two radiuses and this is equal to this is equal to that, you have got a radian. That is about 60 degrees, 59 point something degrees. And that leads us to, at 180, a wide open angle, it's called a straight angle, that's pi. Are you with me so far? All right, so let's see if you really are with me. I'm going to add a blank page, you should too. And let's say that we had a circle where it was open up like that, where that's supposed to be 30 degrees. That's supposed to be a 30-degree angle. Then do you get, a lot of times we'll label it like this, that's 30 degrees, as in, if you follow it back down, that's, the angle's down here, but we would label that spot to be 30 degrees. This is different than when we were doing it on true bearings. Remember how true bearings, the 0 was up here, and we would move this way? It's different. Now, the 0 is here, and we move up from there. All right, so that 30, somebody smart is going to figure out if this is 180, and that's also pi, what's that in radians? Hint, it's less than pi. That's it. How did you figure that out? He said it's pi over 6.
180 is equal to pi, and 1/6.
Another way to think of that is this. Yeah, like what you just said. This needs to be divided by 6. So then this needs to be divided by 6. And what's 180 divided by 6? 30 degrees. So if I want 30 degrees, I could say it's 1/6 of that. So this is 1/6 of pi. So it's pi over 6. All right. Now, if that's pi over 6, you get that this angle right here was pi over 6. And then this angle would be, well, about twice that much. You get what I'm saying? It's got two 30-degree angles, also known as 60 degrees. It's not 90, but it's, maybe I'm not exactly right on how I drew this, but that's supposed to be double the 30, and therefore it's double the pi over 6. It's what? 2 pi over 6. Now, some kids are going to say, can't I reduce that? Sure. What's 2 pi over 6 reduced to? Pi over 3. So this spot is at supposed to be 60 degrees, and it's supposed to be 2 pi over 6, also known as pi over 3. And I like to count them up like this. 1 pi over 6, 2 pi over 6. What does straight up and down make? 90 degrees, also known as 3 pi over 6. You get what I'm doing there? And then do you get that 4 pi over 6 is over here, 5 pi over 6 is over here, and 6 pi over 6, 6 pi over 6, I shouldn't have divided these and left them there. 6 pi over 6, we'll get there, is right here. And then you can keep going. 7 pi over 6, 8 pi over 6, 9 pi over 6. Could you reduce 9 pi over 6? Yeah. What would it be? True. Also known as 3 pi over 2. But if I just keep counting, you see how it's so much easier to go 6, 7, 8, 9. This is 10 pi over 6. Could I reduce it? Yeah, but I'm counting in sixths. What's next after 10 pi over 6? 11 pi over 6. And then 12 pi over 6 means I got all the way back to the starting place. And what's 12 pi over 6? 2 pi. All right, what you're learning right now is super important, and it kind of sucks that it's on a Friday, last hour, because this is going to be used for the whole rest of the semester. Like I'll be saying, okay, it's 60 degrees. What's that in radians? And you'll have to go, oh yeah, it's 2 pi over 6, also known as pi over 3. That's got to become natural. So we just have to have a few of them memorized. Raise your hand. We just have to have a few of them memorized. Here's some that you should memorize. 30 degrees is pi over 6. How do we get that? Well, because 180, here's another fact you should memorize. That 180 is pi. Do you get then if you want some fraction of 180, like half of 180, then it would be half of pi. You get how that makes 90 degrees would be pi over 2? See what I did there? All right, so there's a list of 2 things you should have memorized. I bet you that you know that there's more. What are the other ones that are going to come up a lot? 30 comes up. What else comes up? 60. All right. And I'm going to leave a little gap in there because something between there is handy too. But wait, 30 is pi over 6. I would be okay with you saying 2 pi over 6. But I'd also be okay with you saying, what do you think? Pi over 3. You are correct. 45 is in there. If I wanted to get 45 here, think cutting it in half would be enough? No. What would you have to do to get a 45? It's pi over something, obviously. Pi over 4 is correct. Because, think about it, if I divide this by 4, 180 divided by 4, do you get that there's a bunch of 45-degree angles in there? All right. All right. So pi over 4 is 45. All right. And then there's one last one I think you should memorize. Some of these will be intuitive, some of them won't. This one, I hope, is pretty intuitive for you. 90 degrees isn't pi. What do you think 90 degrees is? Pi over 2. Because get how if 180 is pi, and you divided them both by 2, to get you to have 90 would be pi over 2. So it all comes down to this 180 over pi thing. That's a big deal. All right, so if I was going to ask you to take 2 pi over 3 and figure out what that is, it's a number of degrees. Something you should be able to do. Don't talk back there, guys. I want to change that over by multiplying by something. Hint, it involves 180 and it involves pi. It's 180 over pi. Has anybody learned how to do either stoichiometry or dimensional analysis? All right, you guys have heard of this before then. So then, let's say that I had, for instance, 31 inches. And I want that in feet. You can multiply that by a fact that involves inches. And you put the inches down here so that they'll cancel, right? And what do you know about inches? That there's 12 inches in 1 foot. So then inches cancels, and then I have the answer in feet now. 3/12, and you can reduce that of a foot. What did I do? I multiplied by a fact. This is the fact. Here's another one. Let's say that you get 1.3 euros for $1. That's not a correct, amount. Okay, but let's say it were. Then, if you had $28, you could multiply by, well, you'd put dollars on the bottom, right? $1, 1.3 euro, and then I could cancel the dollars, and I have my answer in euros. I do not have the correct conversion. I can't remember what it is. Okay, let's find out what the euros to dollars is. Okay. Then, if I was given this thing and I was told, hey, this is worth 34 euros. I'm like, I don't know what a euro is. But I could go, well, I'm going to multiply by, put the euros on the bottom. And cancel, cancel. And I could say 34 divided by 1.13. And it'll tell me my amount of dollars that's worth. The reason I'm bringing this up is that this skill works for a lot of things, not just changing into degrees, but that would work. How do I do this? I change it to degrees by multiplying by pi over 180 or 180 over pi. You figure out which is the smart way to do it. Get that changed to degrees. Do it now. Go. And by the way, simplify it so that your answer is not like some weird fraction. Your answer should be like, oh, it's 120 degrees. Figure out how many degrees this is. Now, don't grab a calculator. I do not want you to use a calculator for this. I want you to use, if you can factor it, you should. Did you realize that it was 180 over pi? Awesome. Did you realize you could cancel the pi's? Okay. Then did you think about how the 180 could be broken up? Do you remember the whole if you can factor it, you should thing? Can I make a 6 out of it? Because if I could, then I could cancel these 6's here, see? So maybe 6 times something. 6 times what? 6 times 30. Cancel, cancel. I'm now down to 30 times 2. Final answer, 60 degrees. Raise your hand if you had that one right. Awesome. So I'm going to give you another one. Let's say you had 330 degrees, and you want to know how many radians that is. Hint, multiply it by the fraction, except the other way. And then this one's a little harder to reduce. Your answer's like 13 pi over 12 or something like that. Simplify this puppy. Check with the kid next to you. See if you end up with the same thing. Hint, 330 factors into 30 times 11. 330, if you make that 30 times 11, your life will be easier. I'm going to pause for a second while you give that a try. Okay, I got row 3 and person 5. 1, 2, 3, 4, 5. That's you. So tell me what to multiply by. 180 over pi or pi over 180? Yes, it's you. Is it pi over 180 or 180 over pi? All right, you are correct. And how do you know for sure that the 180 should go on the bottom? You want to get the degrees to cancel. Very good. Okay. And now, tell me, what did you factor it to? Do you remember what hint I gave? True. And this was 30 times what? Excellent. And this would be 30 times what? 6. And then cancel 11 pi over 6. Raise your hand if you had that one right. Okay, awesome. You are quickly getting good at knowing what radians are. All right, now I want you to draw for me on a little circle where in the world is pi over 6. It's a place. If I had said 30 degrees, I'd say you should know it was about there. So you can make a 30-degree angle right there. But that's not where this spot is. Where in the world is 11 pi over 6? Count by 1 pi over 6s. 1 pi over 6, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's true. Did you get a spot right there? Raise your hand if you had that one right. Awesome. Next thing you have to know is, wouldn't there have been a faster way to get there? Yep. I could have gone this way 30 degrees, couldn't I? So that is in the same spot as negative 30. Do you get that 11 pi over 6 is 330 degrees, and I could have got there by going negative 30 degrees. Negative means change directions. Are you processing that? I'll give you another one that's like that. Would you agree that down here, that spot is 3 pi over 2. What's your name? Thank you. Don't make that face. It's just making like 10 people laugh, which is great for you, I guess, but it's messing up my math class. Okay, so this is 3 pi over 2. And what's a faster way I could have got there? I could have got negative 90. Also known as negative, I'm trying to go back and forth between radians and degrees so you get good at it. Negative, how many radians would that have been if I would have gone negative? Negative, how many radians? That's how many radians that would be. Negative pi over 2. Because you remember that 90 was here and pi over 2 is with it. Half of pi, which was over here. So, all right. I know I'm stretching you beyond maybe what some of you can handle. All right, I'm going to just get to the next part that you got to learn before we're done for today. So imagine for a moment you got a circle, and you got this and this and this are all equal in length. Do you remember what that one is? That's what I started with. How many degrees is that? It's a radian, which is about how many degrees? About 60. 59 is better. Okay, good. So that's a radian. Now, what if I wanted to figure out how long this side was? Well, if I told you this was 8, wouldn't it be obvious? This would have to be 8. I mean, the point is that those are all the same. Okay? So if it's 1 radian, it's super simple, but we almost never do it with 1 radian. So what happens if we got a circle, we got an angle, and it's like, oh, let's go with 45. No, it's not. Yeah, it's more like a 45. About a 45-degree angle. And I say that this is like 12 inches long. I could ask you, not how long this is. That would be dumb because that's too easy. What is it? 12. But how about this? There's a formula for that. There's an app for that that does this. And it goes like this. You have S equals theta R. That's a formula you got to memorize. We are not going to give you that on the test. Honestly. Last time you may have noticed we got a couple formulas for free, but there was like 6, and you only got 2 of them for free at the top of the page. This one, you're not going to have written anywhere. You got to know it. S is the arc. That's the arc length. That's this curve right there. It's how long will that curve be. This is the first time that you found a length of a curve other than a circumference. Do you remember that? Circumference of a circle is a curved distance around the outside. And all your other distances are like straight. All right, anyway. S equals theta R is, this side is called S. I hate that name. I like S's because it's my last name, starts with an S. But S's are terrible because they look like 5s. And if you were going to name an arc, why would you call it S? It's like if you're going to have 62 cows, wouldn't you go with C for cows? And if you had 26 chickens, wouldn't you go with C for chickens? But why do they go with S for arc? I don't have that answer for you. All right. But I call it the arc length, just to be snarky. All right. And then this is your angle, but it's in radians, as in you can't use degrees. Why? Because I'm picky? No, because the formula won't work. If you stick in 30 degrees and you times it by R, which is 12, it'd be 30 times 12. Do you think this is really 30 times 12? There's no way that's 30 times 12. It won't work. So you can't use the angle as degrees. You'd have to go 45 translates, oh, I was saying 30 when I meant 45, sorry. But either way, 45 times 12 is clearly not how long this is. That's the radius, if it wasn't obvious. R is the radius. Okay, so this angle in radians, I just showed you. We just spent a little while training. Can you take 45 and change it into radians? Some smarty pantses have already memorized it. Pi over 4, awesome. You should memorize that one. Because then you don't have to do this. This is painful. You don't want to do it every time. Because sometimes you can just memorize them and go, oh yeah, 1:4 ratio, pi over 4. Okay, so this is pi over 4. So S equals pi over 4 times 12. Could you do a little bit of simplifying there? Sure you could. If you can factor it, you should. Isn't 12 4 times 3? Cancel, cancel. 3 pi. Now, I know that feels weird because you're saying a side length is 3 pi, and that seems like how you should be measuring angles. But isn't 3 pi the same as 3 times 3.14? Wouldn't 9 seem kind of reasonable for this? About 9, a little more than 9? And that's the right answer. So the answer is 3 pi. And don't let that freak you out. It just means 3 times 3.14. Could you get a decimal? Yeah, except on this test, you're not going to use a calculator. So you'd have leave your answers accurate. So it'd just be 9 pi. Done. Yes?
How is 180 degrees 5, but... So
Okay, hold on. How is 180 degrees? What?
Well, like, didn't you say 180 degrees is equal to pi?
I didn't say, well, yeah, 180 degrees is pi. Hold on. So here's where pi is, and here's where 180 is. They're in the same spot. True.
And now it's 45 degree angle, 3 pi.
How is a 45-degree angle 3 pi? Okay, I didn't say that this angle was 3 pi. I said that this distance was 3 pi.
So it just goes with the, and then it's like a different value.
So this right here is 3 pi, which is about 3 times 3.14. I know you think I'm talking about this angle. I'm not. That angle's pi over 4. This length is 3 pi, as in 3 times 3.14, which is about 9. It is confusing, I get that, because as soon as I say 3 pi, it seems like I should be finding a spot on the outside of the circle as where 3 pi should be. Nope. 3 pi, pi is just a number. 3 times 3.14 makes about 9. So this distance here is about 9. All right, I'm going to give you one more like that without any help. Would you please try this one before I answer the question that's out there? If this is 10, and this angle is 60 degrees, would you please figure out how long that side would be? That is a typical test question for our next test. Find the arc length. I just gave you a formula. If you've forgotten it because you have terrible short-term memory, you've been drinking too much Diet Pop or whatever it is, yes, it causes memory loss. But I can't remember that because I drink too much Diet Pop. It is, you ready? S equals, who's got it?
Me.
Say it.
S equals the radian thingy.
Which is called theta.
Yeah, times the radian.
Yes. All right. And what is that radian thingy in this case? Who's got 60 degrees already memorized? Pi over 3 is correct. S equals pi over 3. And if you were like, how do you get that so fast? Take 60, times it by 180 over pi, or pi over 180, and it's pi over 180. I personally say if you can factor it, you should. So this can be 60 times 3, and then cancel these, pi over 3. That's a way to do it. Okay, so this is pi over 3 times the radius, which is 10, so it's 10 pi over 3. And I know it feels weird. That's this distance is 10 pi over 3. That's the same as about 10. Why is it about 10? Because it's almost a radian. Get what I'm saying? Isn't 60 degrees really close to a radian? So that side should be really close to 10. But it's not 10. It's really close to 10. Okay. All right. Then there's one last thing I have to teach you, and that's how to find the area of this sector of the circle. Would you agree it's not the whole circle? If it was the whole circle, it'd be super simple. Pi r squared. But it's not the whole circle. It's part of the circle. It's a fraction of the circle. Would you agree that that fraction has to be 60 out of 360? Do you get what I did there? I had 63/60ths of the circle. The 60 came from here. 360 is the total in a circle, so 60 out of 360. What if we had this super smart kid in class, and he said, Mr. Server, couldn't you do that as pi over 3 over 2 pi? What would he be doing? He'd be doing the Radian ratio. There's 2 pi in a circle, and he'd be doing pi over 3 is the radians out of 2 pi. You can do it that way if you want. I personally think it's easier to say 60 out of 360 because I can reduce that easier. But pi over 3 over 2 pi isn't really that hard. I'm going to put it over 1. And remember, this is from the top 20. This is the one of the moments where the top 20 shines because you go, oh, it's just a fraction over a fraction. So I flip it and multiply it. And then I can just cancel these. And the answer is 1/6. That's also 1/6. Would have been easier in degrees in my opinion. But it's one of the reasons I want that top 20 strong is things like a fraction over a fraction are like, no big deal, I got that. If you're thinking to yourself, yeah, that's great, but I still haven't marked on the top 20, come in sometime. Let me help you. You just have to show up. If there's 2 or 3 things that you're not good at, you just point at one on a sheet and say, can you show me how to do that? 5 minutes later, you'll be doing them right. It's not that hard. Just got to ask. All right, so my final answer on this one, I have 1/6 of pi r squared. 1/6 of pi r, what was r? 10 squared. So if I am allowed on this test to leave my answers exact, meaning I don't have to use a calculator, then I can say my answer is 1/6 times pi times 100. To clean that up, I should put the fractions together. 100 over 6 pi. Oh, and I can reduce that. 50 over 3 pi. There we go. All right, let me give you a final culminating question. And we do have 20 minutes left, so you're going to have a fair amount of time for homework, which is awesome. You ready? Here's a circle. We've got an angle. And I'm going to go with a 30-degree angle this time. Right away, your brain should be processing what's that in radian, what's that in radians, because you're going to need the radians. And I want to know if this is a radius of 11, two things. What is the area of the sector? That's this whole piece right here. What's that area? Remember, it's a fraction of the circle. And then, what is the black line there, the arc length? You got a formula for both of those. You need to change that into radians. See if you can do it. Pause for a second while you give this a shot. Okay, final thing. Did you get 30 out of 360 for that part? That part of the circle, which is pi r squared, but our radius is 11. If you simplify that down, you'll have it. Who had 30 over 360, pi 11 squared? Raise your hand if you had that right. Awesome. Now I can go a little further, cancel off a 0. 3 over 36, that's the same as 1/12. Pi times 11 is 121, 11 squared. So it'd be 121 pi over 12 if you want to be persnickety. Okay, then this next one, S equals theta r. SOAR formula. I like to think of it as soaring above the math problems like an eagle. Anyway, arc length is another way to say it. S is the arc length, and it's theta, which is, do you have that memorized? Pi over 6. Very good. If you haven't got that yet, get it. Because just like I told you to memorize sine of 30, and it's come up like 43 times, I'll say it again. What's sine of 30? Some of you still haven't memorized it, lazy bums. 0.5 or 1/2. Sine of 30 is a half. You should also memorize that 30 degrees is pi over 6. It's just going to come up so often. It's like, what's your name again? Oh, I guess I can look it up. You know what I mean? Like, come on. You should know that one. All right. Times r, 11. Final answer, 11 pi over 6. That's exact. Some kid that types in 3.14 and multiplies it out, it's an answer, but it's not exact anymore. I know that feels weird because it seems like that's an angle. That's not an angle. That's a distance. It's a distance. If you want to know what decimal it is, I could tell you it's about 30 divided by about 6 is about 5-ish. It's 5 point something. I don't know. You'd have to use a calculator. Yes?
How do you know it's 6?
How'd I get the pi over 6? This 30. First of all, frankly, I didn't do the conversion, but I'll show you how you could. I had memorized it. Let's see if I memorized it wrong. Would you agree it's pi over 180 or 180 over pi? And I think the 180 goes down here. Do you agree with that? And if I go like this, are we good so far? Cancel, 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 cancel. What is 3/18 reduced to? There you go, pi over 6. Okay, so that's why it's pi over 6. And the radius was 11. All right, you learned a bunch of math. This class is intense. I know. I remember I used to teach regular, and it was kind of fun because the lessons were half this long, like literally. This is 2 days worth of stuff in regular. Okay, so you're stepping up by being here. You have to be willing to take that and be able to process it fairly fast, and you know what I mean? Like our tests come a lot faster because we have to get through this stuff so much faster because we have 4 extra chapters at the end of this class that the other class doesn't. Plus all the labs. We don't have any labs. Okay, so this is a more challenging class, no doubt about it. So, all right. Would you turn now to the assignment? I'll help you find the place where we start. So if you find this page in the notes, you have found the assignment. I know there's some stuff before that, but that's about degrees, minutes, and seconds. I'm just going to tell you this and suffice that instead of the whole page. Do you get if I said it's 120 degrees plus a little more? It'd be nice if I'd have said like 0.3, but they don't do that. Do you get that they might say 120 degrees and 13 minutes. And what does that mean? 13 60ths. Do you remember this from the beginning of the year? We had like one of the days where we changed minutes into seconds, so you divide by 60, and that would mean 120 plus 13 60ths. It's just a strange way to give your answer in degrees and minutes and seconds. All right, so that's what it would be if it was 120 degrees and 13 minutes. What if it also said and 12 seconds? What? Well, this is 120 plus 13 60ths plus 12, and if it's seconds, this was how many minutes were in an hour, how many seconds would be in an hour. Yep. There is a logical reason for this from a long time ago, but now that we have decimals and calculators, it's much easier to do it the way we do it, which is to have a nice little decimal. Like 220.6 degrees is just fine. All right. All right, so I'm saying I don't need you to know all of that. Instead, I need you to know how to do this stuff. So let's get to, hold on just a second. Let's get to these. Okay, what's the direction say? I can't see them. Change degrees to radians probably, or radians to degrees? Okay, so they want you to go and multiply this by 180 over pi or pi over 180. Which one? 180 over pi, and then the 180s cancel? No, the pi's cancel. What's the answer? 180. See how easy that is? Multiply this by what? Should I put the pi on the bottom or top? So what's on top? 180. And then cancel, cancel. And now a little bit of reducing, please. 3 times 60 would be smart. If you can factor it, you should. And then look at that. 3's cancel. Boom, boom. Notice it's negative. Remember me saying negative degrees, just go the opposite way. And then this is negative. 2 times 60 is 120. What am I doing all your homework for? I don't know. All right. So finish that off and do 7 pi over 6. Change that into degrees. You have a question? 2 times 60? Yep. All right, yes. Yep. You just write negative 120. Negative 120 is different than regular 120. Let's make sure you get that. Here's where regular 120 would be. It's like 90 degrees plus a little more. Okay, that's where regular 120 is. Here's where negative 120 is. That way. So that's where negative 120 is. That's where positive 120 is. They go different directions. That's the positive direction. That's the negative direction. Okay, enough of that. Let's move on down to these problems. Sorry that I got stuff written in there ahead of time. I'm having technical issues with my smartboard. I cannot erase those things, so we'll just deal with it. This has an angle of pi over 6, which I already last hour changed over to 30 degrees, and its radius is 12. And then what do they want me to do with this? 2 things. Find the S, which is the arc length, the arc length, but they call it S for some dumb reason, and the area of the sector. There's the area of the sector formula all filled in for you. It's 30 over 360 times pi r squared. I didn't stick in r. That's your job. I didn't do the whole thing. Okay? All right. So I did say that the kids could skip problem 59 here. And we started on that bright yellow page right above this. And then we do these two, 57 and 58. And then you're done. That's it. That's very doable. Be happy that I'm not assigning you that much. But use that to actually be motivation to do what I've assigned you. It really will help. Okay. And that's all I have for the video for today.